Hello students and researchers, welcome to video number 11. In this video, in prior video, we have discussed the measurement model assessment. We have looked at convergent reliability, composite reliability, discriminant validity, etc. In this video today, we are going to shed light, as I promised you, on the structural model assessment. The structural model assessment, the procedure or process, follows 5 steps. In the first step, we look for collinearity issues. We check our model. Does it have or does it face any collinearity issues? Vertical collinearity, lateral collinearity, or no? It is important. Second step, we check the relationships between our variables. In the third step, we check for R-square. Okay? R-square means the impact or the percentage of impact. Usually it is a percentage that exogenous or independent variables have on endogenous or dependent variables. This is the third step. In the fourth step, we look for the effect size, F-square. Okay, and in the fifth step, which is the final step, we look for or we assess the Qsquare, the predictive relevance. All right, then, the structural model assessment in structural equation modeling follows then 5 steps. In this video today, I'm going to provide you with a brief on these 5 steps. However, in coming videos, each step, we're going to take it separately. We're going to discuss it, look for the theory behind it, and then do what? Then demonstrate it in SmartPLS application. Stay tuned. Let's continue our students and researchers with video number 11. In this video, as I mentioned, we're shedding light on structural model assessment. As I mentioned, in this model assessment, the structural model assessment, we follow 5 steps. In the first step, we check for collinearity issues. Vertical collinearity for the measurement models, as we did, and then we check for lateral collinearity, and this is specific to the structural model or the latent constructs in the model, or the relationships between the latent constructs in the model. Step number 2, we assess the significance and the relevance of the structural model relationships. We check the relationships between the models, between the model variables, exogenous variables, endogenous variables. We check how those relationships interact, and then through checking those relationships, we can understand the results of our study in terms of hypothesis testing, etc. The third step is assessing the level of R-square. Okay, we have to check for R-square, and this figure is really important. Usually it's a percentage figure, as I mentioned. Step 4, you assess the effect size. This is F-square. The effect after intervening and just removing some, for instance, some indicators of some variables, we check this intervention, the effect of this intervention on our model. And then finally, in step number 5, we assess the Qsquare, which is the predictive relevance. Okay, for collinearity issues, we have to understand. For collinearity issues, we got to understand that when we have 2 or more variables that are collinear, they mean that those 2 variables are measuring the same underlying attribute of a tangible or intangible object. So both are collinear. They mean that both are doing pretty the same. Like for instance, if we have a construct, let's say we have for our model, which is the banking, online banking use, we have perceived usefulness and perceived ease of use. If those variables are collinear, it means like both of them have pretty the same indicators or the same survey questions, and they are measuring the same attribute. Okay, we don't want that. Okay, we don't want to have collinearity issues in our structural equation model. Variables may be strongly correlated, however, they may have a low degree of collinearity and vice versa. So we have to understand here that collinearity is different from correlations. Okay, we have to understand this thing. Whether we have a formative measurement model or a reflective measurement model, and if you can go back to the video right before this one, video number 10, you can understand the difference between these both models. We have to check for collinearity. This is step number 1 in the structural model assessment or SM assessment. So each set of the predictor constructs need to be assessed separately for each sub of the structural model. We have to check our constructs. We have to check how 2 variables or 2 abstract variables or 2 latent variables are related in terms of collinearity. Usually in the measurement, we have 2 types of collinearity. In the measurement model, we check for vertical collinearity. I'll give you an example in a bit. In the structural model, we check for lateral or horizontal, let's say, collinearity. We have to ensure that we got no collinearity, or at least we meet the acceptable threshold of collinearity before we proceed with step number 2. Okay, if we notice this is an example of vertical collinearity. Okay, you can see, let me show you here, you can see in this, this is the main construct here, and those are reflecting, okay, those are forming this construct, those are the constructs forming this construct. If we check for vertical collinearity, we have to check between those latent variables, okay, forming the main latent variables that we are studying. Okay, so this is the vertical collinearity. You see, we check collinearity among this and this and this and this, and we check whether the indicators of this latent variable are similar or they are both measuring the same attributes of this main construct. If they are doing so, then we have a vertical collinearity. We have to check for every single construct. This is an example here. We got the satisfaction that's being formed by 3 subconstructs here. Okay, we check between this and this, or this and this. We check vertically for vertical collinearity. However, the case of horizontal or lateral collinearity is different, as you notice in this graph or this figure here. Okay, in vertical collinearity, we have, in horizontal or lateral collinearity, we have to check between the main construct and its subconstruct. Okay, if we take, for instance, this as hotel satisfaction as the main construct, and this one is the room satisfaction or the service quality, we check between this and this. We check the indicators and this and the indicators and this and see if they are laterally collinear. This is for lateral collinearity. So lateral collinearity, we may end up having a model that is supported by reliability, validity, vertical collinearity tests. However, we end up having an issue with lateral collinearity. Okay, if we have such an issue, then we have to reconsider our model and maybe reconsider our data or survey questions and do the necessary amendments and adjustments. We'll come to those in coming videos. This is an example of lateral collinearity, okay? This is an example of lateral collinearity. As I mentioned, this is the, for instance, the employee hotel employees, and satisfaction in the hotel. In lateral collinearity, we don't consider that collinearity among those variables or those constructs. No, we go between those two, or those two, or those two, etc. What are the possible solutions for collinearity if we have any collinearity issues in our structural model? If we do have, then maybe we can combine some variables. If those variables maybe are the same, or they are, for instance, leading to the same results. For instance, if we consider our example, the online banking use and maybe software use by customer in banks, if we have these two constructs and we end up finding that those two constructs are laterally collinear, then we end up combining those two and ending up with just one, or removing just one of them. Okay, these are some possible solutions for lateral collinearity or collinearity issues that we may face in structural equation modeling. Step number 2 in structural model assessment. In step number 2, we look for the relationships among our endogenous and exogenous variables. We check for the path coefficient that may range between -1 till 1, and the higher the value, the more or the stronger the relationship. We have in structural equation modeling 3 types of effects: a direct one, an indirect one, and a total effect. That's the sum of both direct and indirect. This is an example here. If we consider, for instance, the relationship between y1 and y3 here, the direct effect between y1 and y3 is equal to 0.20. The indirect effect that goes through y2, so we go this way and then this way, it is 0.8, which is this one, the relationship between y1 and y2, and 0.50, which is the relationship again between y2 and y3. So the total effects would be this one, 0.20 plus 0.40, that gives 0.60. So this is the understanding, this is the relationship and the path coefficient and the effects between our or among our endogenous and exogenous variables in our structural equation model. Assessment of the effects, usually with bootstrapping function in SmartPLS. We assess the effects in our structural model. Bootstrapping is a function in SmartPLS we'll come to in coming videos. It usually estimates what it does. You have, for instance, a sample of 500 respondents. Through bootstrapping, you can have subsamples of this sample and then ending up decreasing or eliminating or maybe mitigating the non-normality of your data distribution in SmartPLS. So, bootstrapping estimates the spread, the shape, and the biasness of the sampling distribution of the population from which the sample is taken. Subsamples are created, as I mentioned. And bootstrapping helps more normality of your data distribution. Because usually, as we mentioned in prior videos, SmartPLS data may be not normal or may suffer from non-normality. Bootstrapping mitigates the non-normality of data. Bootstrapping, as a result, is a non-parametric procedure that allows for testing the statistical significance of various PLS SEM results, like path coefficient, compact alpha, HTM, Rsquare, etc. And it evaluates the direct and indirect effects of all hypothesized relationships. When you got T at a confidence level of 0.05, greater than 1.96, this ends up with a meaningful relationships. In bootstrapping, you got, once we come to this, you may choose between, for instance, 1,000 or 2,000 or 500 samples, subsamples. The higher you go with the number of subsamples, the more time it takes to process. You may need maybe a more powerful CPU or processing hardware in your computer. Usually, the choice of 500 samples is okay. However, as I've seen on SmartPLS official website, they suggest higher than that, maybe a 1,000 or maybe even a 5,000. Step number 3. In step number 3, we assess the level of Rsquare, or the coefficient of determination, that measures the endogenous, the variance in endogenous variables or independent variables as explained, or dependent variables as explained by independent variables. And it is explained as a percentage. For instance, we are studying that online banking use. Rsquare will give us a percentage telling us that those factors that you are studying affect 60% of the variance in online banking use. So this is Rsquare. It is a key figure in your results or in your study. In step number 4, we study the effect size, Fsquare. Okay, usually through Rsquare, we get the help to calculate Fsquare. And now currently in SmartPLS, all of that is automatically calculated. Okay, so through the help of Rsquare, we calculate Fsquare. What does it do? Fsquare has the role of assessing how strongly one exogenous construct explains or contributes to explaining a certain endogenous construct in terms of R-squared. And how much without the construct of the independent variable contributes to the variance in the independent variable. Here in to calculate F-squared, we omit some constructs, okay? We omit a construct and we check this intervention, how this omission will change the relationships, or how the construct of the independent variable contributes to the dependent variable. Okay, so we omit some independent variables and we check this omission, the intervention, or this omission impact on the relationship among the remaining constructs and the dependent variable. So it tells F-square, or the effect size, usually it tells how much an intervention has on the study, impact on the study variables. You can get it in any scenario where you intervene in any, for instance, study research circumstance. You intervene with one variable and you see this intervention impact, or you remove one variable and you check the intervention impact. And the last step in our structural model assessment is the predictive relevance, or Qsquare. And usually this is calculated through the blindfolding procedure in SmartPLS. It detects the predictive relevance of the exogenous variables or constructs where a number of indicators in the endogenous constructs are removed before re-estimating the parameters with the remaining data points. So we have here, we omit some indicators. Okay, we omit some indicators in our model, and we check the impact of the omission of such indicators. And if omitted indicators are not too far off, then we can claim that the predictive relevance of the exogenous construct from the latent variables are high. And what is the threshold here? According to Cohen 1998, he states that 0.02 of Qsquare indicates small effects, 0.15 medium effects, and 0.35 large effects. We will be calculating Qsquare and explaining those in details in coming videos. While in F-square, as we noticed, we take out the construct itself, in Qsquare we only take data points or indicators of the construct. Okay? We take the indicators of the construct to check the impact of our intervention, in compared to taking the whole construct in F-square or assessing the effect size. Therefore, my fellow students, as you notice, 5 steps are followed in order to assess our structural model. Collinearity issues, significance and relevance of structural model relationships, Rsquare, Fsquare, and Qsquare. Thank you for attending this video number 11. In coming videos, as you notice, those steps 1, 2, 3, 4, and 5 will take each a separate video to go deeply in each one of them because they are important. Please stay tuned for coming videos. Thank you.